Hi and welcome. In this video, we continue our journey through bivariate analysis techniques, focusing on modeling linear association. Consider a quantitative variable x and a quantitative variable y, and suppose that we have collected data on these two variables from an underlying population and have recorded data on x as x1, x2, and xn, and the data on y as y1, y2, and yn. After checking their scatter graph in correlation, if the amount of linear relation between the two was high enough, we can model the relation between these two variables using a linear function y is equal to f of x equals to a plus bx. To have this model on the ground, we need to estimate a and b. To that end, we use the following formula: b is equal to n sum of x times y minus sum of x times sum of y, divide by n times sum of x squared minus sum of x all square, and a is equal to sum of y minus b sum of x divided by n to compute a and b. For example, consider the two variables working hours and salary and construct their linear model. We have collected data on both working hours, which is our x variable, and salary, which is our y variable, from 10 employees of a company, and have recorded the data on both of these variables here in the second column and the third column. In this column, we find the product of the two, that is 6 times 8 is 48, 8 times 20 is 160, and so on and so forth. And in the last column, we find the square of the first variable, that is 6 squared 36, 8 squared 64, 9 squared 81, and so on and so forth. Furthermore, we know that n is equal to 10. The sum of x times y, which is the sum of this column, is 2268. The sum of x alone, which is the sum of this column, is 79. The sum of y alone is, and the sum of x squared, which is the sum of all numbers here in the last column, is 641. As a result, b is equal to n, which is 10. The sum of x times y is 2268 minus the sum of x 79, the sum of y 270, divided by 10 times the sum of x squared, which is 641, minus the sum of x all squared, that's 79 times 79. Doing some calculations, we get that b is equal to 2.1. And using the second formula for a, we get the sum of y 270 minus b, which is 2.1 here, times the sum of x, which is 79, divided by n, which is 10. We get a to be 10.41. As a result, the linear model of salary and working hours is salary is equal to 10.41 plus 2.1 times working hours, which is the linear model of salary and working hours. Next, let's play a little bit around this linear model of salary and working hours and predict the amount of salary if an employee works for 8 hours. That is, if working hours is 8, how much would be the salary? We just insert 8 instead of working hours here. We get 27.21, that is 27,210 hours is the corresponding estimated salary if one works 8 hours per day. Next, use this linear model and predict the salary if an employee works 10 hours. Again, we replace working hours by 10, and we get that the amount of salary corresponding to 10 hours is approximately 31,410 hours. If the working hours increases by 2 hours, how much the salary would increase based on model 1, which is this linear model between salary and working hours. What we do is we show the working hours before the increase as working hours 0. Therefore, salary when working hours is not increased, we denote it by salary 0 is equal to 10.41 times 2.1 salary plus 2.1 times working hours 0. After increase, let's show the number of working hours after 2 hours increased by working hours 1, which is working hours 0 plus 2. Therefore, salary 1 is 10.41 plus 2.1 times working hours 1, which is working hours 0 plus 2. Now, what we do is, since we want to find the difference in salary or how much the salary has increased, we find the salary 1 minus salary 0, which is equal to salary 1 is nothing but 10.41 plus 2.1, working hours 0 plus 2, which is this green part here, minus salary 0 is 10.41 plus 2.1 working hours 0. Doing some simplification here, multiplying this minus inside, we get 10.41 minus and minus 2.1 working hours 0. At the same time, we multiply this 2.1 with inside, we get 2.1 working hours 0, 2.1 times 2 is 4.1. Now we see that this 10.41 and this minus 10.41 are cancelling out one another, and 2.1 working hours 0 and 2.1 minus here working hours 0 cancelling out one another. As a result, what is left here is 4.2. That is the difference between salary 1 and salary 0. What we can say is, by 2 hours increase in working hours, the salary would increase by about 4,200 Fs. We can find the corresponding change in salary or in Y in general by a certain amount of change in X variable by the following general formula. Consider y is equal to a plus bx is a linear model between y and x. Suppose that we have applied a change on x from x0 to x1 and denote y0 to be a plus bx0 and y1 to be a plus bx1. Then delta y, which is the difference of y, that is y1 minus y0, is nothing but a plus bx1, which is y1, minus a plus bx0, which is y0. Multiplying this minus inside, we get a plus bx1 minus a minus bx0. Now, this a and this minus a, they cancel out one another. What we get is bx1 minus bx0. Taking b as a common factor, we get x1 minus x0. We know that x1 minus x0 is the amount of change we have applied on x variable, which is delta x. Therefore, the amount of change in y is b times the amount of change in x. That is why when we increase the amount of working hours by 2, the amount of salary is changed by 2 times b, which is 2.1 here. b is 2.1 here. 2 times 2.1 is 4.2. Thanks for watching and good learning.